3 years. And it's definitely a good resource to go to in case you need help with homework or just need to talk to someone in your program to see if they have like any insights or any other resources that might be available to you. And as a tutor myself, I really did enjoy like recommending people to several like online resources that would make them better, I guess, in academia. Some of them were like Paul's online notes or even Khan Academy. So, and some of those resources you might have already been like introduced to several uh, back in high school, but it's always worth it. Like it's always worth to know that several students in college are still using them. So just in case like you run into trouble, it's always good to go back to resources that you've used in the past, or even just ask other people that are going through the same struggle, I guess, getting through college, to see if they have any resources as well. And other opportunities that are available at Tech, if you're also up for the challenge, are to become a research assistant and teaching assistant. I've been both, and the one that I did enjoy the most was doing research. It's definitely like a lot more challenging than classwork because you're kind of given a plan, and then once you have that plan, you kind of go out and explore to see if there are any things that are out there that have already been done, or things that that haven't been thought of yet. And that's really one of the things that I really like about engineering, is that you go out, explore, and create, and you repeat the process over and over again until you get like a good common understanding of what you're trying to achieve. And for me personally, like once you achieve the end goal, it's very like rewarding to see how far you've come, like where you started from, and then how much you were able to learn in like a matter of months or even years to see like the end result. And the other thing is also like I mentioned, it is challenging, but since it is a very small school, you'll more than likely have a chance to do research, and I highly recommend, if you're up for the challenge, to do it. The professors are well equipped with most of the resources that you need to start doing research, and I would definitely like ask around, even as a freshman or even a sophomore, to see if there are any opportunities out there. And the other position that I've done was to do teaching assistant, and the teaching assistant position is also very good. Like if you want to review material from certain classes that you think would help you in your own like 300 level or 400 level classes. So some of the classes that I've TA'd for are thermodynamics, fluid mechanics, and mechanics of materials. And I found that the more you actually teach the material to other students, the more you actually understand yourself. And it's a very rewarding process, because you really don't know the material well enough until you actually explain it to someone who's kind of lost. And that speaks true like to the OSL, like, or the Office for Student Learning, when students go in there and they say like, I don't know, like I'm kind of lost, I don't know what to do. It's like not your job as a tutor to kind of teach them. It's always rewarding when you can teach them and just tell them like, this is what you do, and this is the main concept, and that here are more resources in case you're still kind of lost or need more foundation. And it's always kind of rewarding, like when you're done with all of it. Like when I graduated in May, I was all like, yeah, I was able to get involved with as many things as possible, and I was able to enjoy my undergraduate career. And I feel like that's one of the most important things that you should think about. Here at Tech, like it is very challenging academically, but you gotta also expand yourself. you can't just focus on academia. You got to be willing to get involved in organizations, get involved in research, get involved in teaching. As many opportunities as you can get a hold of, take advantage of them, because you might get interested in doing research, might get interested in pursuing a PhD later. You don't know until you find out and try it. So I always encourage everyone to just go out there, try new things, and trying out a new thing might eventually turn into something that you actually like doing and you'll pursue for the rest of your life. So just keep that in mind.
Yeah, so that's all great advice and certainly really mirrors my path towards becoming a professor, right? I didn't go to tech for undergrad. I was from the East Coast, so I went to school in Philadelphia, um, which I'll tell you about in Meng one time. But much the same as Geronimo, right? I was the student that helped the other kids in my dorm when they got stuck in their engineering classes. And you never really learn anything until you try and teach it to somebody else. So, um, yeah, it's a wonderful experience being a tutor and a mentor, and definitely will push you to excel um, beyond where your other classmates are and everything. And probably part of the reason you're coming back to us in grad school, right?
Well,
Um,
yeah, it's definitely like rewarding. But I'd say like one of the things that you got to that I took away from tech is to not necessarily be in competition with other people. Because there's definitely another person that's way smarter than you, and if you compare yourself to that person, like you're already at a disadvantage. So my advice, like another piece of advice that I would have, is just to compare yourself to the person you were yesterday, because that way you'll actually make more progress in life and you're not so worried about what everyone else is doing. Because once you're worried about what everyone else is doing, you're pretty much just wasting time at that instance. Like, use that time wisely, use that time to improve your skills, to get out there and explore, and don't think about like what other people are doing.
yeah, so to mirror off that, there's a couple of questions here. Talk a bit about the intro to mechanical engineering class, which I'll do. Talk a bit about the research, and then what resources are there to get you towards your ultimate job function, career path, and everything like that. So, and to mirror Geronimo's statement there, yes, you're all coming from very different backgrounds, right? We'll have in the intro to mechanical engineering class, I'll have students that are in probably 4 to 5 different levels of math class based on the high school they came from. Um, some of you probably didn't have the option to take high school math your senior year unless you went to a community college, and maybe there wasn't one in the area that had something for you, or you weren't ready to do that. Um, so a wide disparity in where you're starting, and then so the math is not really what I'm looking to start with in intro mechanical. In the intro to mechanical class, we'll be trying to teach you a couple of key tools for doing engineering, as well as how to work in a group. Um, so those first couple key tools will be SolidWorks, being able to draft your design. Uh, as you progress in your career, that'll become an important skill. On the also, this last year, I had a student that got an internship, um, a year-round internship, just doing drafting. Right, the company would send him some parts, and he would, sit down on the computer and make the SolidWorks models and send them back to them. So it's a entry-level skill that can really get you started, as well as some Arduino coding and some basic circuitry that will be increasingly important as you progress further in the degree. Um, we do a little bit more in Meng 210, and then quite a bit more in uh, controls and mechatronics, and then junior senior design will probably also most projects. So Arduino is the actual language that we'll use in Arduino. It's a variation on C, but um, yeah, but Arduino is the language itself. Uh, but yeah, it's pretty similar to others out there that you may have already had experience with. Um, before I get into the details on the class or the research, I wanted to hit on the topic of what resources to get you to your job function and career path. So each student will be assigned a faculty advisor. Um, there's 4 of us that are faculty advisors for the incoming students, your first semester, and then we split out. One of the things we'll do in the 110 class is I'll put sign-up sheets up at the front of the room, or those of you that choose to take distance classes, I guess we'll have some virtual sign-up sheet. I haven't thought that far ahead, because that won't happen until midway through the semester. And let you distribute yourselves out to all 14 faculty members in the mechanical engineering department. We have specialties in solid mechanics, aerospace, explosives, uh, mechatronics, fluid mechanics. Depending on which really interests you, um, we'll give you the option to sign up for a permanent advisor that's in one of those areas. As you progress through your degree, that advisor will help you pick your classes each semester. Um, and the further along and you get into your degree, the less they're going to do of helping pick your classes, right? You're going to have a pretty good idea what to do. You're not going to need that help. And their help is going to be more in line with, where to look for jobs, um, when to be looking for interviews, when to start thinking about grad school, all of those kinds of things. Um, so they're more from an academic side, how you get towards your career path. And then the other resource that's great for that is career services. So career services will come into the Meng 1 class early in the semester, talk about building your resume, attending a job fair, all those kinds of things. Again, we're a little bit of uncharted territory here. I don't know exactly what will happen with our on-campus job fair in terms of COVID-19 this semester, but we generally have 2 job fairs a year, one in the fall, one in the spring. And as part of the 110 class, one of your assignments will be to build your resume and then go around to the career fair and talk to 3 employers. Not that I'm expecting all of you to get internships. Some of you might not be ready for that. You might not want it yet. Some employers are looking for interns starting their freshman year. Some of them aren't. But I want you to have the experience of talking to an employer in a job fair type setting before you really, really want to get that job. And give you a better idea of maybe what they're looking for, right? If you really, really want to work for, let's say, Intel, it's a nice opportunity to talk to some of their recruiters, and maybe they're not interested in hiring a freshman, but you can get a good idea of what kind of classes as electives you might want to take, and if you want to do a minor or any of that kind of stuff that might strengthen your stance. Or as Geronimo indicated, maybe you talk to them and you find out you really ought to join the robotics club and work with the students there to build some robots and do some things, or some of the other extracurriculars like that. Okay, so I've kind of drifted into the 110 class here a little bit. We'll talk about what content, or we'll talk about career fairs and all that kind of stuff. We'll talk about SolidWorks and Arduino coding. I'll also, about half of the lectures, I'll have an alumni or somebody from industry that's working come back and talk about their career. So what can you do with the mechanical engineering degree? Usually someone from Sandia comes down and shows us a bunch of rockets explode. Usually, let's see what else. I sometimes am able to get one of our faculty as a manager at GM headquarters doing something or other. The last thing he presented was on basically production engineering for the most recent Camaro and how he made a mistake in the design process, and that meant it was really hard to produce. So it was kind of an interesting thing. I also really liked the one a couple years ago. We had someone who programmed the flight simulator for the B-2 bomber come in and talk about that, and making a full bird colonel lose his lunch because the timing was off by half a second between the video and the audio in the flight simulator, and as a pilot he couldn't handle that delay. So a whole wide range of industries and fields that you could go into with the degree, and how they kind of got there, from several of them sitting in the seats as tech freshmen before they went on to those careers. As far as delivering the 110 content for the fall, the lecture itself is probably the largest class that you'll have at Tech. There's usually between 85 and 100 students in the Intro to Mechanical Engineering class. As such, I find it highly unlikely that we'll be able to find a lecture hall where we can all meet in person. So I expect it to be offered some sort of hybrid between some students choosing to be online, some students choosing to be in person. I'm not super sure. I also, usually I have industry speakers come from around the state or around the country to talk to the class. I'm not sure how comfortable they'll all be with traveling to do that. So I'd expect a high percentage of those guest speakers to be talking to us, even if we're in the classroom, through the computer like this. As far as the labs, kind of along the same lines, I think they'll probably end up being some sort of hybrid between online and in person. And I'm working with the TAs here over the summer on what that'll look like, how we can do a project where we work together as a team and build something, how we can do that Arduino coding and then test out your code. There's some software that we can do it, build a virtual circuit before we build the real thing, and we'll probably end up relying on some things like that. The SolidWorks will be pretty straightforward with being able to share our screens and things. It shouldn't be a problem. So, so some sort of a mix between online and in person is what I think that class will end up looking like. Anybody have any questions about the 110 class or the career path type questions here before I jump into what everybody's research looks like in the department? Okay. Well, if you do, just don't hesitate to chime in and, interrupt me or put it in the text. I'll keep an eye out on it. Why do you think mechanical? Oh, so the main reason I think that mechanical engineering is such a popular degree is it's one of the broadest and most general of the engineering degrees, right? You can get a mechanical engineering degree and go into a wide variety of industries. That is true and is not in some of the others. Good question. I am a civil engineer, which you probably didn't expect. So I can certainly speak to the difference between mechanical engineering and civil engineering. If you pursue it all the way to the level of a PhD, there's probably very little difference. I was trained to design big things. I teach students now to design little things. A lot of the processes are the same. The design codes and standards that we use are a little bit different, but that's going to be true of any industry, right? You get done mechanical engineering and you start out in aerospace and then you make the switch later to petroleum, you're going to have slightly different design codes. So in that sense, it's not really that different. How many petroleum engineering students are there? Liz, do you know that?
I don't know off the top of my head, but typically we have anywhere between 10 and 15 every year. But the numbers are actually going down, and it's very market influenced. That particular program is. So if the price of oil is high, we have more petroleum engineers. If the price of oil is low, we have fewer. So
Yeah, I definitely see that. I also see some students switch back and forth between the two, not necessarily going one direction over the other. And that's also a good thing to note here. I wouldn't consider yourself tied to mechanical engineering if that's where you start in the fall, or petroleum or civil. You can certainly make that switch. It's probably easiest to make the switch the first year. So after the first 2 semesters or partway through the first 2 semesters, it's not really going to hurt you very much in terms of graduation date. The only one of the engineering degrees that I think is very specific and separate in the first couple classes that they teach is electrical engineering. But even then, you could probably still finish in 4. It might push you to an extra semester or 2. I'm not super sure. I haven't had a student make that switch lately. So back to the first of these questions that got me up. Difference between civil and mechanical is really the size. In civil engineering, especially in the undergrad, there are a lot more design classes that talk about design of concrete structures, wood structures, steel structures. In mechanical engineering, at least at Tech, we break it out and talk about fluid mechanics and mechatronics and coding that the civils don't spend quite as much time on. The design class is mostly concentrated in the capstone design, so our junior and senior design classes, the 4 semesters of that, and then machine design, which Dr. Ghosh and I teach, which deals with gear systems like those behind me, and shafts and bearings and all of those things.
And that's definitely a class to look forward to.
Definitely a class to look forward to. Yeah. So I certainly enjoyed the design classes that I took in civil. Probably would have enjoyed them had I taken them in mechanical. I certainly enjoy teaching them. And the reason is they really draw together everything you've done up to that point, right? There's several solid mechanics classes you take before machine design: mechanics and materials, statics, advanced mechanics and materials. There's a finite element class. There's also a dynamics class. All of those have elements that pull into what we do in machine design, and you really get to see how all the pieces kind of work together. And you start to see some similarities even between solid mechanics and fluid mechanics in how the equations look and operate. And vibrations class also. So definitely is really interesting, I think, to see how related things are once you get towards the end where they start to pull all together. So I kind of rambled through that differences between the various engineering degrees.
Yeah, well, I guess one of the things that you can talk about is like the design teams that are like the design teams, junior and senior design teams that the mechanical engineering program has.
Oh yeah, I think what did you say is the best engineering for a wannabe inventor? Um, to some extent, depends a little bit what you want to invent. I'd probably say if you're going to be a wannabe inventor, it's probably something along the lines of either mechanical or maybe computer science or electrical or some combination of the three, right? We're not really usually inventing new buildings or bridges, which is civil engineering. We certainly do from time to time invent new design techniques. And we're probably not really inventing a whole lot of stuff with petroleum, but I say that, and then to talk about Geronimo's question, I think some of my slides here, I'll get to the design clinic. So these are some of the design clinic teams. They change every semester. There's currently, the last couple of years, been one sponsored by the Petroleum Research Recovery Center, which is centered out of Tech as well. And they have this process for cleaning water. Rather than doing reverse osmosis or anything like that, they pass it through these nanotubes that have pores in it, and you pass clean water through one direction and dirty water through the other, and it pulls more of the clean water out of the dirty water. So you end up with more clean water than you started with, and some highly concentrated sludge at the end that you can dispose of. So they've used it for a couple of things. One of them is production water from oil wells. That's probably the main reason it was designed in the first place, but also for cleaning water from cheese plants. So down in southern New Mexico, we have some big cheese producing plants that produce a lot of mozzarella cheese, and one of the waste products is water. It's not water that the plant pulled in from the environment, it's just a waste product from the milk. So this actually process has been shown that they can use it to clean that water and actually be able to then use it instead of just letting it sit and evaporate out of a sludge pond. So I guess an inventor could come from any field, but yeah. All right, so the design clinic projects, it's certainly unique to tech and unique to mechanical that there's 4 semesters of design clinic. Most universities, it's either 2 or 1 semester. For me, I believe I had 2 semesters of senior design. We designed a fictitious museum for technology of some sort. I was the structural side of it, and I designed an upside-down pyramid that I then had to figure out how to make it stand up and not fall over. We didn't actually get to build anything. So that's one of the great things about the mechanical engineering program is the projects generally involve building something. So we have one right now for Owens Corning that's designing, they call it a lug, but it's essentially a little bracket that holds up a platinum plate that's used in the process of making fiberglass insulation. And if it's tightened down too far, you'll end up cracking that platinum plate, which is really expensive to replace, both in terms of the cost of the material and in terms of the downtime at the factory. So this students are re-engineering the design for it so that it can't be over tightened. Right? So if you did over tighten it, none of the force actually goes into the plate. So they're designing it, and then at some point it will be produced and tested. That's kind of where they left off last semester, is with the testing. So because the design clinic goes on for 4 semesters, usually the seniors will mentor the juniors, and then 2 semesters later, those juniors hopefully take over and start to lead the team. Whether it's the same team or a different team, some of the teams go for a year, some of them go for 2. Some of them, like the Baja, which is pictured in this slide, are a perpetual team, right? There's new race rules every year, and then they redesign and build a new car or modify a previous car or something of that nature. There's also an aerospace competition team. Sandia has started sponsoring a competition team within New Mexico. So we built a device this year that recorded its environment and monitored for approaching people, right? So had to have sensors both for proximity and then for temperature, vibration, a whole range of other things. And then they got to take it up to Sandia and test it in their environmental testing. So cycle it through temperature extremes and vibration extremes, and then dropping it. They have I think it's a 3-story drop tower. It's bungee assisted. They'll pull it up to the top and then basically slam it down to the ground to simulate impact. So students get to go up and see some of that. That are at least the ones that are on that team. Yeah, so whole range of different projects and things.
So one of the questions that was asked of me was what I was going to be specializing on my master's, and I'll be specializing in mechatronic systems engineering. And one of the reasons why I'm doing that is because as an undergraduate, I had research experience with one of the professors at the Mechanical Engineering Department, whose name is Dr. Kuk-Tae Lee. And I basically began liking the fact of combining mechanical systems with electrical systems and actually making something not good but twice as good, because you're actually combining 2 things that are kind of different nature, but when they come together they make something way better. And like I said, as in your undergraduate career, you have to go out there and explore. That's the only way you're going to find what you really like. And if you don't, then it's just not worth it. Because I can give you the scenario, like when you're like done in May, let's say it's a May and you're done with your schooling, but you really didn't explore, and there are different versions of yourself that actually went out and explored all about, and they became something else other than what you are right now. And you're going to look back and say, man, I should have done this, I should have done that, or I should have taken advantage of this. Why have regrets when you can just get on it? Like if there's ever doubt, I know that I did have some doubt when I was considering graduate school, but that's like a whole different story. And if you're interested about that, then I can talk a little bit about that. But there will always be doubt. But the thing is, like, you gotta just say, what if? Like, what if I do this? What if I do that? What would happen? Like, there's only one way to find out, and that's to do it. Like, you might just stumble and fall and figure out that you really don't like it, but you might find out that you really do like it. And there's always that chance. So take advantage of opportunities that are given to you. And if there aren't any, make opportunities for yourself. Like, go out there, talk to professors, talk to other students, talk to alumni, and see how they went about like getting opportunities for themselves. And that's always definitely worth doing. Like, it doesn't matter if you're a freshman or a sophomore or even a junior or a senior, like, it's always worth doing. Make friends with upper level students. That way they can walk you through some of the opportunities that are available for you. And that's always worth pursuing, like I mentioned. And if you have like any questions about the process or what opportunities you can take advantage of as a freshman or sophomore, there's New Mexico Tech has like career services in the Fidel Center, and then there's always a career fair that happens each spring and fall semester, which I highly recommend going to because you might get an internship there. But due to the events that are happening right now, the pandemic, it's like we don't know what's going to happen with those things. Will they be held virtually online or something to that effect? But just just to say this, like just go out there, find opportunities, and if there aren't any opportunities, to make some for yourself. You might end up pursuing that for the rest of your life.
Yeah, and so to Geronimo's point about getting to meet some of the upper division students in the program, I highly suggest joining ASME, American Society of Mechanical Engineering. It's a club within the department. It's probably the largest of the mechanical engineering clubs. There's a couple of others. Robotics is cross between mechanical and electrical. SAE is involved with, that's automotive engineering, so the Baja car, but they've also got a little club. And then AIAA is aerospace. I'll talk a bit about Dr. Hassan Leon and his research, and he's the sponsor for that club. So yes, I think there's a couple of other questions here that have come up, but I think I'll hit them when I go through the research. So we've got second year of design clinic involves. So the second year of design clinic is really more seniors leading the teams. It also, because it's a 2-year thing, allows the projects to be bigger and more involved than they would be elsewhere. So you get some management experience as well as tackling a bigger problem than you might have done if it was a single year project. So wide variety of research within the department. Some of the things here, this is an older, well, let me go back to the beginning of this actually. So these are most of the current full-time faculty at New Mexico Tech. Dr. Ford and I are the ones that are teaching the design clinic class. She does technical writing, which we tie into that class. As far as specialization, Dr. B and Dr. Wei on the left side here do fluid mechanics. Dr. Zagrai and Dr. Hassan Leon do aerospace engineering. Dr. Hassan Leon is mostly drone flights. Hassan Leon, Zagrai, and Dr. Lee all do mechatronics related topics, so robotics. Dr. Rue, Zagrai do sensor systems, so structural health monitoring. Dr. Hargather, Dr. Lim, who for some reason, oh, they're right in the middle. And Dr. Kimberly do explosives. Dr. Kimberly also does fluid mechanics, or sorry, solid mechanics, not fluid mechanics. Dr. Kimberly, Dr. Ghosh, myself, Dr. Rue are all solid mechanics faculty. So you probably noticed some of us hitting more than once in multiple areas. So there's a lot of interdisciplinary stuff going on even between individual faculty. Dr. Musabi did MEMS sensors, but he's leaving us this summer. And we're replacing him with 2 other faculty. One of them is related to the area of structural health monitoring and solid mechanics, and then the other one is in robotics and mechatronics. So I won't have too much on their the two new folks research, other than it sounded interesting when they presented it at their interviews this last semester. So these are just some neat little images from some of the research, and then I have a couple of slides here that go over specific folks' areas. So Dr. Lim does a lot of modeling with explosives, um, with a couple of different topics of interest. One of them is looking at the failure pattern of materials when they're exposed to that rapid shock of explosives, and how the failure of, say, a pressure vessel changes based on the rate of the explosive or the loading event. Not necessarily even explosive, just any of those fast dynamic events. And so, yes, a lot of his work is done up at EMERTEC, which is the Energetic Materials Research and Testing Center up on the mountain. Generally speaking, our 110 class will go up to the mountain, and I'll have you all design a catch box, essentially, to stop shrapnel. And we'll set off a pipe bomb and see whose 12-inch by 12-inch shield does the best job of stopping the debris. EMERTEC will take care of the explosives and everything. You as the students and me as the instructor, the only thing we'll be involved with is making those actual shields and then going up to watch from a bunker on top of the mountain. So Dr. Hargather, I also mentioned, was explosives and fluid mechanics. So he does a lot with Schlieren imaging. So that's this top image here where you're seeing the shadow graph of the waves propagation, modeling that, as well as tracking it through experimentation. Again, a lot of his research is up at EMERTEC. Actually, his main lab is on the EMERTEC campus, because a lot of the research that he does is not classified, but it's not open to the public per se. So a lot of DoD and DOE funded research. He's got his engine down there below. He also does testing various types of rocket fuel and engine. All right, so Dr. Kimberly it mentions kind of a cross between the solid mechanics and the explosives. So impact high strain rate events. So the Kolsky bar, which is basically you take a solid steel bar and you use air pressure to shoot it down a tube and impact your sample, which is that bottom left corner there, crushing that sample. So usually it's done in compression. He's also got one where you'll do it and you pull the sample apart in tension. Actually, you still crush the sample, but the way the sample is designed, it fails in tension, which is kind of interesting. So he also teaches a lot of the computer modeling classes, like finite element analysis. So analysis of structures in the computer, essentially. All right, so Dr. Ghosh, solid mechanics, water desalinization, some composite structures. He has a lot with biomimicry, or bio-inspired design, right? Those are similar but slightly different terms. He's got a helmet system, or excuse me, is really more of a material that's a combination of solids and liquids, and looking at the way and the rate it's impacted gives it some properties for dissipating impact. One of the possible applications was helmets, and also other possible applications are disseminating heat, right? So if you've got a single source of heat, letting the fluid within the structure disperse that heat around the rest of the structure instead of it being concentrated. So Dr. Lee, you're doing research with Dr. Lee, right, Geronimo?
Right.
Maybe I'll let you talk about him rather than me talk about this old slide.
All right, sounds good. So yeah, so I've done research with Dr. Lee, and one of the research that I did with him was last year, where we developed an algorithm for a multi-agent system. So what those systems are basically drones, and we were trying to figure out how efficient a system of drones would be flying in a V formation. So as some of you may know, birds, when they migrate, they fly in a V formation to travel longer distances. And the reason they do that is because it's more efficient that way, due to the drag reduction in each specific level of, or let's say in each specific row of birds. So like the first bird, it would be considered the leader, and then he would be, or let's just say it would be exposed to the most air resistance, but the row that follows that bird would have a drag reduction. And then there would be like an upwash vertex due to the flapping of the wings of the birds, and that then lightens the load for the birds that follow. And we developed an algorithm that would change the leader of the flock to alternate depending on which let's say we have one bird in the front and then two birds that follow it. The algorithm that we propose would give the leader position to the bird that had the least amount of energy left in it. And the reason we did that is because if we immediately got rid of the bird that had the least amount of energy and put it in the leader position, then it would switch back all the way to the back of the V formation, and then it would be saving energy. That way, when it's back to the leader position, the overall flock would travel a longer distance. And in that paper, we found out that the efficiency is there, and Dr. Lee and I think Dr. Hassanalian went a step further and actually did a theoretical simulation as to how much the efficiency would be, and that's on another paper. And that's the research I did with him. And one of the things that he's working on now, I haven't joined him yet, but it's basically he's working on a multi-agent optimization for disaster response. And what that would be doing is, let's say there's some sort of fire in like a forest scenario. Instead of sending human beings, we would be sending robots to explore the area. But one of the most obstacles that you have to avoid would be like the trees, the rocks, and other things that are out in nature. And so you would have to I guess get an algorithm to avoid all those obstacles, and actually like make sure that it optimizes to not waste all that energy, and to most efficiently explore the environment for anyone that's out there. And like another possible application for what he's doing is he's also trying to, let's say that you're trying to protect some endangered animal. You can also use drones to actually map where that animal spends most of its time, and then once you have that data, you can allocate resources to protect that animal from any dangerous things that, for example, poachers or something like that. So that's one of the things that he's doing. I'm not too familiar with like the other things here, but I could, if you're interested in his research or are interested to learn more, I could definitely talk more about it once I read more on it. But yeah, if you have any questions, just let me know.
I think most of the other things on this slide are related to those topics, just using similar algorithms and things for different applications. So thank you. That's actually probably more detailed than I could have gotten.
Yep.
So I mentioned Dr. Ru. He does a lot with structural health monitoring. He's got a couple of different new types of sensors he's developing. This one pictured on the right here, there are these little crystals. This is number 2 on that, where the cursor is, a tiny little crystal. The crystal, when strained, will emit light. So he's looking at embedding that in, say, the wing of an aircraft, and then if the wing were impacted or otherwise damaged, it would strain or deform that crystal when it deformed the surface of the wing, which would emit light. And either you have a sensor that picks up that light and it doesn't actually draw power, would be the ideal, right? As the light hits the sensor, it generates the power that sends the signal back to the central processing unit that detects the damage, right? So you're effectively implementing sensors into your aircraft that don't require extra power and let you know the moment that there's damage developing in the structure. So that's kind of like the holy grail of structural health monitoring, right? If you've got a sensor, the only thing better would be a sensor that adds no weight, draws no power, and lets you know the instant there's damage, right? That would be the perfect. But this one, we've got to add a little bit of weight. He's also got some sensors where it would make the energy storage device, the nanocomposites, part of the structural material of the aircraft, right? So your structural members would also be your battery, or your essentially capacitor storage of power. So a lot of cool things there. Skip over Dr. Musavi. And Dr. Groh is currently a oh shoot, I'm going to script the word, adjunct professor. He now works at LANL full-time. So his research area is robotics, disposal robots, force feedback to the user, all of those kinds of areas. So again, somebody that's left the department, you may have met and seen some of his groups before when you toured campus, but still actively involved through that adjunct status and in sponsoring teams and things like that. Dr. Musavi works a lot with Dr. Lee and a lot with a lot of the other of us, developing drones to do tasks. A lot of bio-inspired design from birds and butterflies and other flying creatures. So he will definitely be one of our guests in 110 talking about the whole drone area and biomimetics. I believe he's giving a talk as part of one of these spotlights later in the summer as well. Dr. Zagrai, again, structural health monitoring, different types of sensors. Piezoelectric sensors are the main thing that he works on, a couple of others as well, but to some degree, aerospace or aircraft engineering, but more on the side of spacecraft. His sensors can test and evaluate how you're putting the craft together, right? If you install the sensors the panels, then they can check and make sure that the bolts are properly tightened and all of that kind of stuff as you're assembling the device, as well as evaluating it in flight and once it's in service out in space. So a lot of interesting stuff there. Dr. Bakhtiarov does a lot with fluid mechanics. He also, for a time, was, I guess, before we launch any nuclear-powered spacecraft or satellites or anything like that, there's a number of checks that go into place. He was on sabbatical for a number of years from tech, and he was that last civilian that signed off before it went to the president's desk. So worked for the Air Force in that capacity up at Kirtland Air Force Base. So a lot with modeling of those type of materials and behavior. Dr. Wei works a lot with other faculty on modeling fluid mechanic structures, so a lot of overlap there with what Dr. Hargather is doing, and fluid mixing and drag on vehicles and things like that. Myself, so my area is primarily solid mechanics in terms of my background coming from civil engineering. However, most of what I do at Tech is either teaching or outreach efforts. Unlike the other 13 faculty members in the department, my position is teaching focused, teaching and service focused rather than research focused. So the research that I do is actually within that realm of teaching. I've had some grants dealing with developing the Meng 110 class, and some other grants dealing with outreach events. So you see the picture in the bottom right there, some students and I went to, I think that one was at Albuquerque Convention Center, doing some displays and demos and things. Maybe I met some of you at some of those events. But not necessarily trying to always recruit for tech at these events, but more encouraging kids from a young age to consider STEM careers, right? So hands-on demonstrations and things like that. The big one I'm looking to get funded next will be one of our senior design teams went to a robot combat competition last year. And so this, or I guess 2 years ago now. And then this last year, we had two teams, one developing a robot for the competition and another team developing arena so that we can start to hold our own competition at Tech. So I'd like to develop that into a STEM outreach program for local middle schools and high schools, community colleges, to all bring their bots together and have kind of a sports league type event at Tech every year, or around the state, and then championship at Tech. We'll see how much interest we get. So yeah, that was me. Dr. Ford, like I said, technical writing, incorporating that into our design clinic classes. I believe that's the last one I have a slide for. The other question of we had up there as I was going through biomedical science, yes, that certainly is an area. I believe one of our new incoming faculty in the mechatronics area is involved in that directly. You need to be. Do mechanical engineers need to be good programmers? I got that question. Yeah, kind of, yeah. Would you?
Yeah. I would say it's definitely a good thing to know. For example, one of the, I don't like calling it a programming language, but one of the program languages that you first learn is MATLAB. And it's just basically it's kind of just like talking, honestly. Like there's really not that. It, it really gets you thinking about the coding that you need to do, but it's more easier to program than, let's say, C or Python. But it's very similar in syntax. But one of the things that you will be doing with MATLAB is projects in classes. If you don't want to do hand calculations that are repetitive and you really don't gain anything from doing them over and over again, you're better off just writing some program that will do them for you. And a good example of that was machine design, because machine design is such an iterative process. If you change a parameter somewhere, it's going to change other things elsewhere. And so if you code it, you won't have to worry about, oh, I changed this, so I have to go and redo those calculations. Instead, what the program does is you change this parameter, and what the code does, it changes those parameters. That way you won't have to manually go and do it yourself. And that saves you a lot of time. So do learn programming. It will save you tons of time.
Yeah. Yeah, whether it's programming in MATLAB to just help you automate some of your design calculations, or it's actual Arduino coding, or it's C, or something a little more advanced, it's definitely beneficial. We have an advisory board of industry folks that give us feedback, and it's always something they say that given the choice to choose between a pool of applicants, they'll definitely gravitate towards the ones that have some coding experience. It will just help them acclimate to the job faster and be more productive. That's not to say that every mechanical engineering student is an expert coder.
Yeah, there's
But
definitely that, but do make friends with people that are good coders. That way you can learn from them. And then there's also a lot of sources in the internet, like MathWorks for MATLAB and Stack Exchange, to name a few. One of the questions I was asked was, did I spend a lot of time debugging my code? Yeah, you will spend some time, but it's good to debug code, because that means you're actually understand what the program needs to do. If you just sit down, try to code without a plan, you're basically wasting your time at that instance. So the way that coding works, the way I like to do it is I sit down, come up with the plan, and then execute the plan. It's just like writing. Like, you got to brainstorm before you start writing. But yeah, don't like you can still sit down and just start coding, but it's definitely a lot more challenging to do it because you don't have a plan. So a good quote that I know is like, an idiot with the plan can be a genius without one. So as long as you have a plan, as long as you stick to it and you know it's going to work, you're better off with it.
Yeah, my first coding experience, and I use the word coding very loosely, was back in 5th grade, and I'll probably date myself because I don't think any of you will know the software. But there was this program called Logo that they had at my, I went to the same school from 1st grade through 8th grade. So it wasn't really an elementary or middle school, it was kind of a combination. So they had this program, and green and black screen, right? Well, I guess no, it had color at one point. You would direct these turtles to drive around the screen and make lines. So going through my head, planning it out, I was going to have this turtle draw a tree. It turned out by the time I ran the code, it looked awfully lot like a horse. So I changed the drawing I was making, and instead I made some horses attacking a castle. Because my tree didn't look like a tree. So yeah, planning out your process before you get started is definitely key to being able to code effectively. And then, recognize that you are probably going to have to spend a bit of time going back to review it. Even in civil engineering, coding in that sense of your design was certainly, yes, C would be a great language to learn.
Can I plug the OSL for a second?
Yeah.
So the Office for Student Learning is the tutoring center for tech, but several of our tutors are also really good at MATLAB and can help you if you're struggling in class and need help or assistance with coding. We have tutors who are, very well versed in MATLAB, C programming, and some of the other programming languages that are used in the undergraduate curriculum at Tech. So if you need help, come see us at the OSL.
Yeah, and please don't be scared off. We're talking all this about coding if you don't have any experience. I would probably say of the 80 to 100 incoming mechanical freshmen, maybe 20 of you have some solid coding experience. Maybe another 15 or so have a little bit, and most of you probably don't have any. You'll probably have some students in your lab, some friends you make that are in those 30 or so that have a bit of experience beforehand, and you'll pick it up. We've certainly got OSL to help you with that. The TAs in the lab will have some sort of office hours as well. Yeah. And if you're looking for a field where you don't have to do coding, it's going to be hard to find. I even had to do it in civil engineering, write our design calculations. They're too involved to do them all by hand. Nobody would pay you enough money for the time it's going to take you to do them all by hand. So even there, it was C and MATLAB were kind of expected. And I think that'll be true across all of the majors, right? You get into computer science and there'll certainly be even more advanced languages that you just have to be able to use. But even in the less computer-oriented fields, it's really become useful. Even the folks that, we have some alumni involved in mining, and they use mechatronics and coding to maintain the equipment and improve its efficiency and all that kind of stuff. Geronimo, any particular assembly language that you would?
Assembly language. I haven't had too much experience with those. Like I've only done some C, some Python, and some MATLAB, and like in classes, you're like in mechanical engineering classes, you're like almost all the courses are tailored to MATLAB. Just because like all the computers at Tech have MATLAB and it's easier to access. So I don't want to comment on assembly languages at the time because I don't have any experience with them. But if you're interested in learning them, I know the electrical engineering the department teaches some of those.
Yeah, I think most of the students I've advised that talk about learning that are the ones that go and get a minor in electrical. Yeah, so that's certainly something that you should expect, that any field you go into, you're probably going to end up in an office working on a team that involves an electrical and a mechanical and a computer science engineer all working together, or an electrical, a mechanical, and a petroleum engineer all working together, or some variation thereon, where you're drawing on specific specialties of some of those other folks to be able to do and pull everything together.
Sort of.
Okay, I hate to break this up, but we going on 5:15 now, and I know some people are needing to go home to dinner. So I just wanted to see if there were any last questions for Dr. O'Malley or for Geronimo. before we close out today's session.
Okay, so one of the questions is, would you recommend a minor in electrical engineering? Is it more desired in the job market? So myself, I did get a minor in electrical engineering, but like I tailored it to things that I was interested in, like mainly circuits, like analog electronics, digital electronics, and some upper level courses that would help me understand more of the theory involved in systems. And I would say that like it does give you a little bit of an edge over other mechanical engineers. Like if you want to get more experience in another field rather than just keeping it in mechanical engineering. So if you're willing to do it, then I would say go for it. Does anyone else have any questions?
While we wait a minute, I'll just echo that, yes, minors can be very valuable. As someone who got a dual major, I have 2 bachelor's degrees, one in civil and one in architectural engineering, completed in the same time it would take to get one. That was crazy. I don't advise my students to do that. I took 21 credits every semester until my last one, when I went down to like 12 because I had run out of classes to take, and it was wonderful. Try and start out at 15. I know the flowchart doesn't, but try and move an elective class like a social science over some summer and start out at 15 and make the adjustment, get your lottery scholarship underway. As far as the minor, yes, they can be very effective. Electrical, aerospace, explosives, all of those. To some extent, if you're looking at going on to grad school, we'll take the explosives one, for example. Getting a bachelor's degree in mechanical with a minor of explosives and then going on to pursue a master's in explosives, you probably better serve to just take those explosives minor classes and apply them towards your master's. You probably don't need both the minor and the master's. So I would make that little caveat there, that if it's going to be in the same thing that you're going to go get a master's or a PhD in, maybe just start towards your grad degree. If it's going to be outside of that field, right, like Geronimo is doing, he's got a bachelor's in mechanical, a minor in electrical, and then going to pursue a grad degree in mechanical. That's a great combination. Or if you're just ending with the bachelor's, it's certainly great to have a minor. So that's certainly something to talk about one-on-one with your advisor as you start to get to the point of needing to take minor classes. Most of the minors, with the exception of like the biomedical and biology and chemical engineering, you're probably not going to take any classes towards the minor for at least 2 or 3 semesters until you've got some of the math and other classes down. And if this raises any questions for anybody else that you think of after, my email is curtis.o'malley@nmt.edu. Feel free to email me. I'll do my best to get back to you in a timely manner this summer.
That's an excellent segue into tomorrow's event, which is Ask Tech Anything. Dr. O'Malley is going to be hosting that event tomorrow, which will take place on Discord, the NMT Peer Mentors Discord server. So if you have already joined the server, just hop on to the Ask Tech Anything channel tomorrow at 4 p.m. And Dr. O'Malley will be there, and we'll also have another visiting alumni, and they can both answer questions if you think of anything after today's session ends. I want to thank both Dr. O'Malley and Geronimo for hosting today's session. It was really great having both of you, and I know that the students appreciated your information about you, your experience, and insights you have about the program at New Mexico Tech. So thank you so much.
Thank you. And I'll have to get instructions from you on how to get onto Discord before tomorrow.
I've got you covered. Don't worry.
Okay, thank you.
All right. Thank you, guys. Everyone, have a good evening.
Thank you all.
Yep.
Nice to meet you.
Thank you.
Good evening.